This is the second problem. Kindly read and understand what is being required. We are given the gas constant and the specific heat at constant volume of the gas. From these two values, we need to find the specific heat at constant pressure and the specific heat ratio of the gas. In the next sub-question, we are also given the mass of the gas, and it is said that this constitutes a non-flow system in which a constant pressure process is performed. The initial volume of the gas is also given, along with its initial pressure. Now, since we know that the process occurred under constant pressure conditions, the initial pressure is also equal to the final pressure. Lastly, we're given the final temperature of the gas. From this given information, we need to find the change in internal energy and the change in enthalpy of the gas in kilojoules. To solve for the specific heat at constant pressure, we just need to add the specific heat at constant volume and the gas constant. This formula will give us 1.16 kilojoules per kilogram Kelvin. Now this value, along with the specific heat at constant volume, can then be used to solve for the value of the specific heat ratio. We now get 1.381 for our value of K. Now to get the value of the change in internal energy, we just use the form mc sub v delta T. However, the value of the initial temperature is not given in the problem, but we can compute for it using the given values of the initial volume and pressure. Substituting these values in the formula, we will get 488.6 Kelvin for the value of the initial temperature. Now that we know all of the needed values, we can now compute the value of the change in internal energy to be equal to 1425.4 kilojoules. Lastly, the change in enthalpy can also be computed using the same manner, but now using the specific heat at constant pressure instead. By substituting all of the known values in the formula, we can now compute the value of the change in enthalpy to be equal to 1968.48 kilojoules.